Okay, welcome to the next video. So we have all those six sprints, a detailed task were created. Of course, we can um, look into the Kanban board for each one of them. So there's a very detailed task list available. So let's look into the first sprint. So this sprint, it's very simple to have a look at it. It's basically whether it's an epic or not, whether it's a critical task or not, or epic story, whatever it is, the descriptions and which agent is assigned to, and then you'll also find, if there are any points to the system. The point system is basically based on the complexity. So based on the complexity, whether we have, an additional point for any of those tasks, then that becomes even more critical and high priority. But anyway, we are going to resolve this using AI. So the time it takes to generate any kind of system artifact is not going to be so different. So let's run this in a flat way that take one by one and run this run the sprint. So let's say let's ask the AI. Let's start executing sprint one. Take each epic story or task, move the status to in a proper hierarchical order and change before executing the activity. Change the status to in progress and provide the deliverable. Once it is completed, then change the status to done. Make sure there are no linter errors. If there are linter errors, because some of the relations need to be created later, in that case, move the status to blocked, and you can come back later to execute the blocked status. Do this for every epic story and tasks. So what we are saying is, okay, when you take an epic and look into the story and then look into the task and change the status accordingly if you are going to work on it. Yeah, so it basically opens up, from the backlog and then take each task and make progress. And if there is any errors, of course, we cannot complete it. So in that case, get into blocked and then come back and take the next task and complete the next one. So first move all the epic story tasks to open. Afterwards, okay, so ensure the deliverables are created in the proper folders. Okay, so I think I have given all the instructions, but let's see how it is going to execute. So you don't have to do anything, just watch and see how the AI is executing the whole sprint by itself. So let's move on. Okay. Okay. So first of all, we said change all the statuses from backlog to open. Okay, it looks like there are some errors. but it's already fixing it up. Okay, good. It is fixing it. There are no errors. So now it's going to start work. Okay, so based on our task, it is creating its own to-do list as well. So now it's changing from, so you saw that everything is changed from backup to open. And then there are no linter errors, of course. And then it takes the first task. So it's executing the first epic. So change the status. Starting the first epic, change the status from open to in progress. So epic and task also moved to in progress. So the work is being done. So let's see. Okay, it is creating the deliverable product line. So let's see whether it's going to create in the right project folder, or otherwise we may have to help the AI to create the folder and then move the files accordingly. But at least it's creating the deliverable. So let's see where it is going to create. So let me close this clang or Silang help as well, so that it's clear for us when it's creating the artifacts. Okay, it detailed. Oh, okay. So product line. So this is under product line, and then we have several linter errors. This is not the real syntax, so it needs to know. Yeah, it identified what the syntax is, so it's going to correct it. So it corrected. No linter errors now. Awesome. Well, this is our linter errors. Now the task is done. Okay, so the whole epic story and task is moved to the done status. So it has completed the first one. Now it is going to take the next one. So this is the first time I'm giving a rec file to import and create a Clang rec file. So let's see how it is going to create the rec file. So now it is in progress. As you see, the tickets are moved. So just waiting. I'm really curious to know how the rec files are going to be created into a .rec file. Okay, it is trying to understand the rec file more. Okay, it's trying to find the rec help. So it is now reading the rec help file. Okay, it's now creating a rec file. So from the recif, it is now creating a Clang rec file. So that is interesting. I've never done that before. So let's see how the output is going to be. It's going to be a large file because there are so many different requirements. I think at least it has 30 to 50 requirements. I don't know exactly because I haven't opened the Reiki file in a more readable format. It's an XML format, and I'm not able to read everything. So we have to wait and watch. Okay, It's created, so it's nearly 390 lines. So let's look into it. Okay, so description, rational verification criteria. Oh, okay. So yes. Oh, this is really cool. And like type functional. So there are some safety requirements. There are some functional requirements, and this I'm not sure whether this safety level comes from the record file, because here everything is or majority of the functions are okay. It has completed that particular task, so that's good. Okay, let's accept this. We can go through, of course, um, to understand whether these are meaningful ones. But you can see that there are no errors overall. So you can also see in a document view. So there are about 20 different requirements, and you can be more in a document view. So valid part condition, system shell. Okay, it's running here. So the system shall determine, and so on and so forth. So we have we have all those requirements are now more in our CLang format. And while it is creating the the next files and so on, I want to show you another interesting thing is the traceability graph. So that you can see the traceability graph already in this one. So you see here, there's really these many nodes already created for this project, and you can clearly see that the requirement specification. Oh, okay, it's been it's updating, so it's not showing the best one. So there are more items have been created, so that's why it's not able to show it properly. But let me open it again. Probably once this UCD is created, it's going to refresh once again. So here you can see all these requirements are isolated right now because it's no traceability available. But when we see here, the sprints and different things are connected to each other. Um, So for example, if I say sprint 6, the sprint 6 has different deliverables that are connected to sprint 6. So the sprint system is very much traceable. But let's wait for all other artifacts so that you can see how everything is connected. So you see that it's fully AI in AI running the whole development um, of this product. Yeah. So currently it's in system development. So what it has done is out of 8 epics in sprint one, 3 epics were completed. Yeah. So let's look into different files. Okay. So there are use cases, uh, name, function, and so on. So if I go and have a look at the use cases, okay, because if you see the use cases, these use cases have the actors define primary actor and the secondary actor, but there are no functions. So that is exactly why we have this CLang or CLang framework, is because when you develop certain things, it has to be linked with each other. So that means an use case cannot be an independent entity. The use case is coming from the functions that those are needed. So if there are no functions, of course, the use case diagram will not be created. So, so that's something missing. And what we will ask the AI to create is, so for example, if you go here to understand how the use case syntax would be, the use case is basically how the connections are. So use case, and then you have to really show which from which actor to which function, how the connection between those functions are. So what we have to ask is basically before getting to next epic, can you create system level functions so that those can be used in use case diagram? Right now, there are no functions used in use case diagram. See syntax here. So you can, okay. So even though we did not put it in another task, we can ask the AI to create or update the use case diagram, which means you need to have a function file that needs to be created. So let's wait and see whether it is creating a function file. Okay. It's creating a nice system functions file. So those functions need to be referenced inside the use cases so that the diagram can be populated. Right now, as you see here, driver is a primary actor, and then the secondary actors are autonomous parking control, body control module, EPB actuator, instrument cluster, diagnostic tester, and so on. So all of these things are connected to our functions inside the Safe Park Supervisor module. So let's wait until it creates the system functions. Okay, the system functions are created, so no errors. But now the system functions need to be um, referenced in this in this use case diagram. I was just checking whether this is operational scenarios use cases. Yes, it is operational scenarios use cases. So let the AI update the functions accordingly. So I have this diagram open. Let's see. Let me need to refresh this diagram once the UCD update is done based on the functions which are defined there. Magically, all those functions came in. So the functions are all now defined. As you see here, the user and the diagnostic tester. So the diagnostic tester, oops, is using provide diagnostic access. So that's the function. Yeah. So if we are using the there's a change autonomous parking controller. Oh, okay. So there are a few things the driver can, as for a safe parking. Autonomous parking controller can also ask for safe parking, and the diagnostic tester is used to provide diagnostic access. So let's look into this once. So process autonomous request and provide traffic jam assist. And then we have process manual effort and so on and so forth. So there are several functions available here. Okay, so that's an example how the use case diagram can be created. So use case diagrams are very simple to produce. You don't have to do anything to draw any diagrams. So diagrams are auto-generated from the uh, from the um, from the instructions that's provided. So that this is basically the code for use case diagram. It's a very simple one. Um, yeah, I'm not sure why we have this from two is kind of mixed up a little bit. But that's really not the right syntax. So from actor, so I think I need to validate a little bit, but here, you see the basic understanding that this is how the use case diagrams are getting created. Okay, so let me run all those epics and let us come back and see where, how all these artifacts can be created. Okay, in the next video, I'll show you once all 8 epics of sprint 1 is completed. Thank you.